Welcome to this session on what's new and what's next in Oracle Machine Learning, new features and roadmap. In this session, we'll get an update on the new features in Oracle Machine Learning and a look at what lies ahead. I'm Mark Hornick with Oracle Machine Learning Product Management, joined by Sherry LaMonica. And if you have questions during the session, please post them in the Q&A and we'll address them either there or live at the end. This is Oracle's Safe Harbor statement, since I'll be discussing the OML roadmap. We'll start with a brief overview of the OML components, take a look at some of the new features recently released with the demonstration, and then highlight features on our roadmap. So let's have a brief overview of the OML family of components. Now, OML for SQL provides a SQL interface to the in-database algorithms, which keeps data under database control, eliminating the need to extract data to separate machine learning engines, which is a key part of the OML value proposition. The resulting machine learning models are first-class database objects, meaning that you can, for example, include them in SQL queries or control access by granting and revoking permissions, audit user actions, and export and import machine learning models across databases. In-database models enable both batch and singleton scoring directly from SQL queries, which is great for developers already working with SQL. Now, in-database models also provide explanatory prediction details, so you can understand why an individual prediction was made. Now, being part of the core database, OML for SQL is available on all database versions with no installation required. Now, OML for Pi and OML for R are Python and R language interfaces. These allow you to manipulate database tables and views using familiar Python and R functions on data frame proxy objects. And they also provide Python and R language interfaces to the in-database machine learning algorithms. OML for R and OML for Pi support what we call embedded execution, where you can store user-defined functions in the database and invoke them on database spawned and controlled Python and R engines. And in OML for Pi, we also provide an API supporting automated machine learning, or AutoML, which includes automated algorithm and feature selection and automated model tuning and selection. Now, for interface or interaction with autonomous database, we provide OML notebooks with SQL, PL/SQL, R, Python, conda, and Markdown interpreters. Users can schedule notebooks to be run automatically, and notebooks can be shared in a variety of ways with other users on the data science team. As we'll mention in a moment, OML Notebooks now has an early adopter interface based on technology from Oracle Labs. Now, Oracle Machine Learning AutoML UI is a no-code user interface that automates model building, selection, and deployment, and OML Services is a RESTful service for model management and deployment, data and model monitoring, and cognitive text analytics. OML Services supports application development using REST endpoints, and you can also deploy models from the AutoML UI directly to OML Services in just a few clicks. And finally, we have Oracle Data Miner, a SQL developer extension for creating, scheduling, and deploying analytical workflows through a drag-and-drop user interface. But before we go any further, I just have a couple of questions for you. First is, which OML APIs have you tried so far? SQL, Python, R, or REST? Please select all that apply. Certainly have an early lead for OML for Pi. We've got a competition there with OML for SQL. So let's see, we're coming in at about 2/3 have OML for Pi, roughly half for SQL, a little more than a quarter for R, and about 20% for our OML Services REST API. That is a good showing. All right, well, thank you for that response. And now let's take our second poll question. Which OML user interfaces have you tried? The OML Notebooks, the AutoML UI, Oracle Data Miner, or the OML Models interface? That's pretty great. We have about 100% closing in on OML Notebooks. It's well over 90. Then we have more than a third using the AutoML UI, about a quarter for Oracle Data Miner, and 20% using OML Models. So that is a very decent response. So thank you for that information, and we will continue. We're going to jump into the OML new features. Now, this summarizes the major new features introduced since the beginning of 2021. The most recent addition is Automl for Pi 2.0 with support for date and timestamp data types and additional in-database algorithms. We released a new notebook interface, Automl Notebooks Early Adopter, as well as the ability to custom install third-party packages. In March, we released a range of functionality on Automl services. So let's take a closer look at a few of these. With the release of Automl for Pi 2.0, we introduced support for date-related data types, as well as direct integer support. With the Automl datetime type, represents columns with database types date and timestamp. And there are related types that support the difference between dates or times, like Automl time delta, and support for time zones. Automl for Pi also exposes 3 additional in-database algorithms: time series forecasting using exponential smoothing, feature extraction using non-negative matrix factorization, and XGBoost for classification and regression. You may recall that XGBoost is an in-database algorithm that's available since 21C. See our announcement blog for more details, but let's take a few code examples involving dates. Now, using the SH schema's sales table, one of the database's demo datasets, we see the column time ID is of type date. And we can obtain an Automl data frame proxy object using Automl sync. From there, we can compute statistics using the overloaded describe function, which processes the computations in the database. And we can extract date features like year and month as separate columns so they can be included in further analysis or machine learning modeling. Now, another recently introduced feature is the Automl Notebooks Early Adopter interface, which is based on technology from Oracle Labs, and it offers a whole host of benefits. You'll experience faster notebook load times, both Jupyter and Zeppelin layouts, richer visualization, individual paragraph comments and dependencies, and even on-page notebook versioning, version history viewing, and version comparison. To help you take advantage of this new interface, we've made it easy to convert existing notebooks to the new interface. And you can continue to use both environments for a while longer, and then we'll automatically convert all notebooks to the new interface. So let's have a quick demo of the new Oracle Machine Learning Notebooks Early Adopter interface. We're looking at the Automl user interface. And so first we'll click on Notebooks. And this will bring us to the notebooks in our existing Zeppelin interface. One of the first things we may want to do is copy an existing notebook into the new early adopter format. So we'll select our notebook and we can say copy to Automl Notebooks EA. This makes a copy of the notebook with the suffix EA appended to it in our Automl Notebooks EA listing. Now we can get to the new interface in 2 ways. One, in the upper right-hand corner, we can go to Automl Notebooks EA, or we can go to our cloud menu and also click Notebooks EA. So we see that our notebook Automl modeling demonstration is here. Let's click on it and see what it looks like. Now we're ready to use the new interface with our notebook. I'm going to switch to another notebook that I've already prepared in this interface to highlight some of the features that are there. So we're going to go back to Notebooks EA for our listing, and we're going to click on Automl for Pi Time Series ESM1. So let's highlight a few things from the new interface. First thing is we can certainly run all of the paragraphs just by clicking this run triangle, but we have a few other features. We can look at versioning. So perhaps we want to create a new version, and we're going to call this version 2. Give it a description of my second version. And now I can look at the version history. And we can select these. We can delete, compare versions, or restore an earlier version. For exporting notebooks, we have a few options. We can export all of the contents, or maybe we want to exclude the code to only show the results. Maybe we just want to exclude the results and show the code, or exclude timestamps because it's irrelevant when the code was actually run. We also have a few export types. The native Data Studio representation contains all of the metadata that works with this interface, but we may want to export an exclusive Jupyter or a Zeppelin notebook to share with other users who don't have the richer Data Studio environment. We can easily change the service level between low, medium, and high. In this case, we'll change it to high, and we are confirmed that it's indeed been updated. We can also view our paragraphs as a Zeppelin format, as we see here, where we're changing the width of the paragraphs, to Jupyter format, where they have a different orientation. Let's go back to the Zeppelin interface. Now, there are other features like showing the code across all paragraphs or hiding results. We can even enable read-only mode so that we don't accidentally modify the code or the results from the notebook. So first, we're going to run our Python paragraph that will create our Python interpreter for us. And then we can do also a couple of other things here. Here we have a comment that was made. This is our opening paragraph for Python. Other users can add comments to facilitate data science team collaboration. We can also create dependencies to say, what are the paragraphs that should be run when this paragraph is run? We can come down and select additional paragraphs that should be run as a result of running this first paragraph. And so we'll just say save. So now by running this first paragraph, we see that it ran both this second paragraph and the third one just a few seconds ago. Now we can expand a given paragraph to see it in full window view, and we can, of course, collapse it back. We can easily view line numbers within the paragraph, and we have a number of visibility settings for the title, the code, even the result, and the settings that are associated with that. And there are other settings that you can do to move paragraphs around, as well as clone paragraphs, disable them for run, or delete them. So let's just look at a few other visualization capabilities. In this case, we're going to use the iris data set. And you'll see here that we have a box plot, and there are a variety of settings that we have which show the multiple series at once grouped by species. We can also customize this with visualizations, whether we want it to be horizontal or vertical, interquartile range, showing outliers or not, and then also to have the description where we have the title set up with various parameters for color and font size, subtitle, as well as footnote. But we not only have box plot, we could look at this with a sunburst, in which case we're looking at a plot of the iris species with radius as the sepal width. We could also look at standard pie chart, bar charts, and of course go back to our box plot. But now, since we're in this time series notebook, let's just take a quick look at the OML for Pi interface for time series. So we have our data set that we're using here, which is the SH sales data. We're going to pull out the time ID and the amount sold and get a proxy object for that from OML for Pi. We see that we have about 900,000 rows available to us. And the data records that we're going to be working with, as we said, time ID and the amount sold. Now we have some documentation we've included in the sample notebook that shows some of the settings that you can use to affect the time series algorithm. You can also get online help, in this case for the oml.esm function. Next, we'll build the model. We're going to create a Holt-Winters model using quarterly parameters. So what you'll notice is that we're building the model. We have the run indicator going across the bottom, and we're setting the accumulation interval at the quarter level. We want to predict 4 quarters ahead. We're using the Holt-Winters algorithm, and the seasonal cycle is 4 quarters. We're separating the predictors and the target from the training data set and feeding that into the algorithm. So now we have our model. We could look at a few other things to see the model itself. In this case, we're looking at the settings that were actually used by the algorithm, global statistics that give us a sense of how well this model is performing, and the predictions. Now we can review global statistics and model quality here by accessing the global stats parameter, as well as to get access to the predictions themselves. Now to visualize these, we're going to use the line plot. And this is going to retrieve the original value and the predicted value. And we're showing the series value and prediction grouped by a time sequence. There are various customizations that we can do for the visualization. We may want to do a polar coordinates chart instead, so perhaps more of a spider chart approach. We can do stacked and unstacked, sorting, different zoom settings as well. But for each series, we can indicate things like, what is the line type? Perhaps we want it to be curved as opposed to straight or stepped. We can also assign the specific fill color to individual series or to all of them at once. And there are other settings as well. Now we can also go to SQL and access the model detail view as indicated here, and we'll add a couple of other series, in particular, the lower bound and the upper bound. And again, we see the series that we're showing with the date. And that concludes our demonstration. So another new feature involves OML notebooks, where you can create and use custom conda environments containing your favorite third-party Python and R packages. This continues to expand Autonomous Database as a platform for data science and machine learning, where you can supplement in-database functionality with that from the broader R and Python communities. Using your admin credentials, you can install third-party packages in conda environments and upload them to Oracle Object Storage, where you can then download them and activate these conda environments. And they can be used directly in OML notebooks, in your Python and R paragraphs, or also in combination with embedded execution from OML for Py and OML for R. Now this shows using the conda interpreter in OML notebooks to create conda environments. On the left, we create one for Python called mypyenv with the Seaborn and TensorFlow packages. On the right, we do the same for R with the conda environment called myrenv using the forecast and ggplot2 packages. Next, these are uploaded to object storage, simply using the upload command. Now you can download one or the other environment in your notebook and start using the package functionality. Here, we're using the Seaborn package to produce a pairs plot on the iris data in Python and visualize results from a forecast in R. The next new feature we'll cover is OML Services Data and Model Monitoring, which expands support for the data and model lifecycle and MLOps. There are several aspects to monitoring. Data drift involves identifying when the statistical properties, like distinct values or mean and variance, change significantly. And this helps to maintain data quality standards separate from or in conjunction with machine learning. Model drift involves identifying when the user-specified model metric, like accuracy or R-squared, significantly changes, or the distribution of predicted values deviates too much from the initial values, and this may signal the need to rebuild your model. This currently supports in database models only, but we plan to expand this to support the ONNX format models as well. Also new with OML services, we've added batch scoring endpoints for in-database models. As you have heard in previous sessions, OML services scoring functionality supports singleton and small batch scoring using synchronous REST APIs, where input data is provided as part of the payload and the output returned in the response. In support of longer running jobs like batch scoring, we introduced asynchronous requests, which avoids blocking the client process while scoring occurs. And this enables scoring batches of data that reside in the database or accessible to the database itself, for example, using external tables. Now, this feature allows using the same REST API as you do now for singleton and small batch scoring, but doing this at scale in the database. Both the data source and scoring results remain in either the user schema or the schema that the user has been granted access to. Scoring occurs directly in the database for optimal efficiency. The results of batch scoring may be consumed by other applications, including those built using Oracle Apex, to visualize data trends and interpret the analytic results. OML Services supports batch scoring for regression, classification, clustering, and feature extraction models. Here, we're showing a curl command for a batch scoring job. On the left, we're using a pre-obtained authentication token, details about when and how often to start a job, and on the right, the job properties about the model to use and the data to score. With the Automl UI, we've augmented this to support integrated text mining, where one or more columns of unstructured text are automatically handled for feature extraction or tokenization. Here, we combine structured and unstructured data to potentially increase model accuracy. In this case, if the type of the column is a varchar2 greater than 4000 or a CLOB, character large object, this triggers the treatment for automated text feature extraction. Now, a second feature involves optimized algorithm settings for high cardinality classification targets, and this helps to improve the overall performance and scalability. This occurs behind the scenes automatically. Okay, so let's take our next poll. Which of these recent new features are you most likely to try, or have you already tried? Is it OML Notebooks, support for third-party packages on Autonomous Database with OML for Pi and OML for R? Perhaps it's OML for Pi date and timestamp support, or the OML Notebooks early adopter interface. Maybe it's OML services monitoring, or OML services batch scoring for in-database models. So the results are coming in, and it looks like we have over 2/3 that have tried the OML notebook support for third-party packages, or they're most likely to try that. About 1/3 of you are talking about the OML for Pi date and timestamp support. The early adopter interface is coming in at about 1/3, another 1/3 for the OML services monitoring, and services batch scoring for in-database models. All right, that's great to see. Excellent. Thank you for sharing that information. So now let's move on to the OML roadmap. Sliding our timeline to the left, we highlight what's coming in the next 12 months or so. With Oracle Database 23c, we have multiple enhancements, which I'll say more about shortly. We released OML for R 2.0 on Autonomous Database, but we'll soon release it for Oracle Database, along with a common standalone client for access from your favorite IDE. OML for Pi 2.0, which we just released for Autonomous Database, will also be made available for Oracle Database with an updated standalone client. And we're planning support for GPU compute resources through OML Notebooks and OML for Pi to enable deep learning and other use cases on Autonomous Database. Well, let's look at a few of these in a little more detail. We'll first talk about bias and fairness. These are important aspects of machine learning models to help ensure against putting certain groups or individuals at a disadvantage. And this can occur, for example, in data where certain groups are excluded or underrepresented, or in models where distinct populations may have been combined, resulting in adverse outcomes. You might imagine a healthcare scenario, right, where the model predicts how a patient may respond to a particular treatment. An underrepresented subgroup of patients may be predicted to respond well, when in fact, this is more representative of the larger population and not the subgroup. On the topic of monitoring, recall we introduced REST endpoints for data and model monitoring. Well, coming soon is a no-code user interface for specifying your data monitoring jobs along with visualizing the results. Later in the year, we'll also be providing a no-code user interface for model monitoring. Now, for a data monitoring UI preview, here are a few screen captures that highlight a few things. How to specify a job, which involves identifying the baseline and new data, the repeat frequency, the starting time, among other options. And it will visualize changes in data statistics. Users have a quick visualization of the drift and whether it surpasses the user-specified threshold. And opening a monitor job that was already run, we can see individual features and how their distribution changes over time, as shown here at the bottom. And we can get even deeper insights into changes in individual column data using different metrics. Here we're showing the population stability index for the column amount sold. We also see a numeric summary along with a visual display of the statistics from the baseline and recent test data. If you specified a crosstab column, like the product ID, you get a frequency table containing the fraction of the distribution across the two columns. Now, on the roadmap for Automl for Pi is the ability to reproduce the no-code Automl user interface pipeline programmatically, so that Python developers can replicate the Automl UI functionality more fully. We'll also augment Automl for Pi's AutoML to compute quality metrics in the database for increased performance and scalability, including algorithm-specific metrics. Automl for Pi will also enable programmatically deploying in-database models, and later ONNX format models, to Automl services. And this helps Python developers to seamlessly script their modeling workflow for real-time and streaming applications. There are also a few more in-database algorithms we plan to expose through the Python API to achieve greater parity between the SQL, R, and Python APIs, as listed here. Now, in the case of Database 23C, note that these features are already available in the developer release, but I included them here for our roadmap as they'll appear for Oracle Database more broadly, and then, of course, the Autonomous Database. There are several core database enhancements that we'll take advantage of. First has to do with Boolean data type support, where you may have a Boolean target, like whether the customer churned, and we want to use a Boolean to represent that in our table. Another is support for tables with up to 4,000 columns. And this allows enterprises that have, say, customer data with thousands of attributes to analyze them at once without doing any additional processing. Today, Automl supports data with more than 1,000 attributes using the SQL nested column type. But this 23C feature enables native table and view support for many more columns. There are some other enhancements as well, but I'm going to move on to a few algorithm-specific enhancements. One is for explicit semantic analysis, which supports text analytics feature extraction. ESA will support integrated text mining for in-database algorithms, meaning that the more powerful ESA algorithm will perform the feature extraction to complement other structured data in the table before building models. ESA will also support doc-to-vec dense projections with embeddings, and this is geared towards enhancing the use of structured data with unstructured data, such as call center rep notes on customers or physician notes on patients. In the case of generalized linear model for classification, we're adding additional link functions for enhanced support of binary targets, among other uses. Now, for extreme gradient boosting, we've expanded support for survival analysis, which is particularly useful when predicting equipment failures and health outcomes. And we're also enabling feature interaction constraints and monotonic constraints so that data scientists can further limit variable interactions. Last on this list here is the time series forecasting algorithm, exponential smoothing, which has a wide range of hyperparameters. And this enhancement automates hyperparameter tuning to produce better models without manual or exhaustive search. Also related to time series exponential smoothing is multiple time series in support of time series regression. Now, multiple time series supports conveniently generating backcasts and forecasts on one or more time series in the same table or view. The identified target time series also has confidence bounds computed for it. Now, the output of multiple time series serves as an input to other machine learning techniques like regression. Time series regression is a powerful technique that supports one or more time series as predictors, along with flag variables like holidays or events. In the example on the right, we show predicting a meter reading, where temperature is a predictor time series, and we combine this with other structured data. For example, flags for special events like promotions or holidays. The algorithm performs backcasts and forecasts for each time series in this example. Here we have temperature. You can then feed the result into a regression algorithm like XGBoost to predict the target time series. Here, the meter reading. Here's a code example that highlights the additional specification of the series list, where we specify the additional time series we'd like to have processed. The time series in this list will have backcasts and forecasts produced in the resulting model detail view, along with the backcasts and forecasts for the target column. But as we said, the target column will also have the upper and lower confidence bounds generated. let's touch on enhancements to the Automl UI. First is experiment scheduling. OML Notebooks currently supports defining jobs to schedule the running of notebooks, and the same capability will be made available for AutoML experiments. We'll also be adding a new machine learning technique, time series forecasting, which supplements the classification and regression techniques already supported. This will support use cases like forecasting demand, sales, and inventory, without having to worry about hyperparameter tuning or algorithm selection. This leverages the 23C algorithm enhancement we just mentioned for ESM. And lastly, we'll touch on GPU support, which increases the set of AI/ML use cases supported by Autonomous Database, including deep learning in support of image processing models and even LLMs. For OML notebooks, we're focusing on Python paragraphs, where a notebook could seamlessly use an environment with packages that leverage GPU computing resources. Access would be transparent to the user. For OML for Pi on Autonomous Database, running user-defined Python functions through embedded execution could be specified to use GPU compute resources, whether you're using the SQL or REST APIs. All right, so for our last poll question, which roadmap items are you most looking forward to? Is it the OML AutoML experiment scheduling, multiple time series enabling time series regression, automated time series search, the data monitoring no-code user interface, or perhaps GPU compute on OML notebooks and OML for Pi? All right, some of the results are starting to come in. We have about 2/3 responding with GPU compute. That's very high on the list. The data monitoring no-code user interface gets about 50% of the response. And we've got about more than 1/3 for the AutoML experiment scheduling, and about 1/4 interested in multiple time series for time series regression. Automated time series search is about 15% support on that. Thank you all for your responses to that poll. So for more information on Oracle Machine Learning and to get started using OML, check out these resources. In addition to our webpage and blog, see the OML GitHub repository, which contains code examples and notebooks using SQL, R, and Python APIs. Of course, you know about our OML office hours, which provides updates on OML technology. We have a rich library of over 70 recorded sessions with component how-tos, use cases, and product demonstrations. And these have been viewed over 50,000 times. To try OML on Autonomous Database, check out our Live Labs workshops. The link here is for the OML Fundamentals Live Lab, which covers several of the OML components that we've discussed here. So if there are any questions, Sherry, have any come in? Do we have anything that we'd like to discuss?
Yeah, there are a few questions about the conda environments. For OML for Pi, does the Python version have to be 3.10? And I answered that with OML for Pi 2.0, we requires Python 3.10. And the next question was, can you use the conda environments with embedded execution? And the answer is yes. You can use the R and Python conda environments with the Python, SQL, and REST APIs for embedded execution. And just to note that the REST API for embedded execution is only available on Autonomous Database.
Thank you, Sherry. All right. Well, if we have no further questions, then I thank you for joining us for this session, and we will see you next time.